We will officially start now, and we already switched to English. Hi, everybody. I would like to welcome you in front of Symphony, and I would like to thank you for attending yet another one of our online meetups. My name is Merima. I'm the community manager of our Sarajevo Hub, and tonight I will be your host together with my colleague Slavica.
Hi. Hi, guys.
Slavica will give you more information about the flow and the structure of the meetup, and then we will leave the stage to Damir. I hope you are all set and I hope you're all comfortable. And of course that you will have fun and most importantly that you will learn a lot from Damir because he prepared a really interesting presentation for you. Just in case you missed some parts of the meetup, just like Slavica said, don't worry, we will make sure to contact every one of you afterwards in order to provide the presentation and the recording itself of the meetup. That is it from me now. I will leave it up to Slavica now and to Damir. Enjoy.
Yeah, I will take it now. Should I say who I am again because you mentioned it already a few times. But I'm Slavica, as you already know. I'm community manager in our Belgrade hub, and as Merima said, we will be your host today. Okay, so some ground rules you need to know. Feel free to also ask all your questions in the question box below, and Damir will make sure to answer them after his presentation. Even though if you don't have any questions and you would like to contribute to the topic and share your thoughts, feel free to do so. So if you don't have any questions and just want to say something, just raise your hand or just unmute yourself and do it. Any other non-technical questions will be also answered by Merima or me or our colleagues from Symphony. So don't worry, everything is covered. Also make sure to stick with us for 5 more minutes after the meetup because we prepared a quiz for you and some super cool prizes if you are fast enough. That's why pay attention and note some key points from Damir. Now it's time to start with what we are really here for. And Damir, are you ready?
Sure. Okay.
Okay, good luck and enjoy the presentation.
Okay. Okay. Hi, everyone. My name is Damir. I'm a solution architect in Symphony in Sarajevo Hub. And I would like to thank you all for coming. And I hope you'll have fun and maybe learn something new. So for start, I'm just going to share my screen. Just a second. Can everybody see my screen okay?
Yep.
Okay, cool. So the topic for today's meetup is distributed transactions in microservices, or the subtitle says the order in chaos. So first, let's see what's the problem and why would this topic be something that we can actually talk about. So traditionally, if we worked on either smaller apps or in the past, we would have probably a monolithic application with a single database, and the transactions would usually be handled by database itself. However, in recent decade, microservices have emerged as a very, very dominant and promising and very useful thing. And the transactions, while still we can use database mechanisms, are not so simple as they were. So we are just going to scratch this topic, and as a point of all meetups, it's just a way to maybe inspire conversation, discussion, maybe to think about problems, because microservices and their architecture, and as well as handling data, is a huge topic, much larger than time allotted for this meetup. So we are just going to explain the problem through several types of implementations, going from the monolith to assumed microservices to actual solution on 2 types in 2 ways, and touch a few patterns that we can use in order to keep our data consistent in microservices. So let's, the entire meetup is made as a solution to a simple business requirement. This business requirement is actually from real world. Of course, the company name and exact names of everything are omitted due to disclosure, but it's something that you will probably see a lot in a lot of different systems. So our business requirement is that we have a company that can sell a specific type of product as a service. And customers paid for that product using money they have in third-party parties. Yeah. And what we get in our systems are notifications that payment has been made and what customer wants to buy. And also we have to make sure that every time that payment is made, that we check that that specific product or service is in stock, that we can actually sell it, and that the balance of the customer is maintained and adjusted accordingly to the payment that he made. But we have a few constraints. These are typical constraints if you're familiar with any type of transaction. So if we have to update a few entities inside our business requirement, we want to either update them all or fail the operation itself. So in this case, we have to create a payment record, a transaction record with a status of what happened. And we want to update the customer balance, and we want to update the stock. So if transaction is successful, we want to decrease amount that we have in stock, and we want to decrease customers' outstanding balance. And if either of these criteria is not met, we have to roll back these changes, and we have to declare transaction as failed. So let's see how that would look in a system with no microservices or any service-oriented architecture where we do not have to use database per service, so we have a workaround on these types of things. So we would probably have a single app, either a single or load balance, does not really matter. And we would have an ACID-compliant database, which has 4 tables, for example, customer table, payment, transaction, and stock. And we want to do this implementation using these elements. So in code, that would look something like this. So this is all code examples are in Spring Java. So I tried to keep them as simple as possible, so there are no special Spring features or anything like that. This would be just like a standard API. We have a single payment API, which accepts a payment request. Payment request itself has a customer ID, so which customer made the payment, amount of money he sent, ID of the item he wants to buy, and the amount that he wants to buy. So in database, we have the 4 entities that we talked about. They are really simple, and we have checks on them saying that balance cannot go below 0, and also that in case of stock, it cannot go below 0, because if we do not have that item in stock, we cannot sell it at this point. And in transaction, we have the ID of the transaction, status, and the references to payment and stock. So how would this service look like? So we have transaction service because in our requirement, we want to save the payment record and transaction record no matter what. So if payment arrived, I need to have record of it, because it does not mean it's either failed or not failed, but I need to have record of it. And also transaction, because it has to be either successful or failed. So here we will just save a new payment, new transaction, and we will go to the process. Inside the process, we have updates that we made to the stock and that we made to customer, with one detail that this is actually transactional, and we'll see what that means now. So if we run this app, and also during this run, if you have any questions, because we'll have some of these build times from time to time, I'll try to answer them in these short breaks. If not, then after the presentation itself. So we have this app up and running. if we go to our database, we have 0 records here, as you can see. Just a sec. Okay. And we seeded some data from the seed script that actually seed a single customer that has a balance of 100 and has an ID and has 2 stock items, which all have amount of 10 and also its IDs. So let's try to make a sale. So we'll just send this request saying that this customer is sending amount of payment 20, wants to buy a single item, and see what happens. So we have a successful transaction. And if we go to the database and check it out, we see that this is decremented. So that's correct. We have 9. And if we go to customer, this is also decremented. Oh, sorry, that's not the correct one. If we go to customer, it is also decremented, and we have a record of transactions saying that it failed, right? So this is all pretty simple so far. So let's try to do something that we cannot do. So let's notice here back in the code that we want to update stock and then update customer.
Damir,
so let's try.
Sorry for interrupting you. Can you please make font larger, because audience is asking. I think it's small, really small, so it's not.
Okay. Just a second. Let me see how that works. Is this good enough?
I think it's much better than before.
Okay. Sorry. So I can make it larger like this, or just tell me when to stop.
I think it's good now.
Okay, thanks. So we have to update stock and update repository. And currently we have inside the repository, inside the customer, we have a balance of 80. So let's say that we try to send amount of 100. So that should put us below 0, and that should not be allowed. And as we can see, we have a failure here. And if we check the state of the database and check the customer, it is unupdated. If we check the stock, it's also at 9 as well. So our business requirement works. So this will fulfill everything. And that's basically everything that we have to do in case of Monolith application. So why does this work? This works because we can rely on ACID standard of database that we are using. Here we are using Postgres SQL, and we can just use that transactional to make sure that all the updates inside it are either executed in its entirety or not executed at all. And we can control that using that mechanism. And that's possible because everything is on a single physical machine in a single process. That's where that is happening. So problem is solved. So why would we need to do anything else? Why would we need microservices at all? I mean, if they're just going to put additional complexity into this. So this example that we had is very simple. We have usually this single payment, and the single scenario is one of hundreds, if not even thousands of scenarios that can happen. And these entities are not only touched by these operations. They're touched by various types of operations. For example, stock can be modified by payments and by actual inventory movements, and after sales movements, like if something is replaced or goes out to a different warehouse and things like that. So these entities are controlled by different business domains entirely. And this code base will grow as we implement more and more of these. huge code base usually will cause anti-patterns to emerge. And even without anti-patterns, if we have this entire code base here, deploy times will grow, build times will grow. And if we are one of the good developers and we have good test coverage, then that will grow as well, because we will have a lot of test cases on every deployment to do. And also data store can be quite tricky. If we rely on a single database, that database will eventually become very, very large. And scaling that horizontally poses challenges, because you can only use type of replicated system or partitioning. And doing that after we already have a huge monolith, which has a huge throughput, can be a bit challenging. And scaling vertically is just unrealistic at some point, because if we have a server with terabyte of RAM now, it's quite expensive. And if we need 10 terabytes, it's almost impossible, right? I think it is impossible. I don't think we have a service like that anymore. So what we try to do with microservices is do divide and conquer. So we will try to split up all of this into smaller things that can be tested, built, and deployed faster. And we want to prevent creating huge code bases, because microservices are meant to be small. And we are going to shard the data in a way that it can be worked by a single microservice. So we are trying kind of to solve this issue from multiple sides, from builds, deployments, code base, and data store. But that, as you will see, is not without challenges. So let's see how we can do this simple business requirement now. So based on our scenario, we will probably have following services. So this is not set in stone. This is not something that you would always do. This is something that could logically come out of this monolith. So we have a stock service, we have a payment service, and a customer service. So the payment takes care of these two entities, customer of this one, and stock of this one. In reality, all of these three services would have much more tables than just these one or two. But for our business requirement, just for demo purposes, this should be enough. So let's see how would that look like in code. So if we go back to our idea and go just simply here, we will zoom in again. So we have these new modules. So what we created here is a customer service, payment service, stock service. Can I zoom this in? No. Sorry. Gateway and contract. So usually just microservices by some definition is you should not share anything between them by some people. But as I read a really cute comment on Stack Exchange, says, if you do this, people think that Martin Fowler will come and eat your soul, but that won't happen. So I'll take that risk now. So we have these three, and we just divided the code between them. So in customer service, we will still have a customer entity, same as it was before. We will have its repository and a service that will just update customer. So we'll just take customer by ID, decrease its balance, save it, and we should be done. It's still transactional. We don't need it to be because there is a single operation here, but let's just keep it that way. Same goes for stock service and payment service. We will take payment service as the first in our approach. If we go to the payment service, it will be the main one. It will have the same API as we had before. So a payment made, we have a payment request, same one as before. And in service, we'll have a few changes as well as entity. If we take a look at entities, since these are now separate databases, we can no longer have a foreign key. So in a previous one, if we take a look here inside the transaction entity itself and payment entity itself, we have a reference to the actual customer. But we cannot have that anymore because this is on entirely different machine as far as we know. So we cannot rely on that. And what we would keep is just customer ID. So something that we can actually reference the customer that made this payment. Transactions we can't because they're in the same domain. And that's basically it for the entities. And inside the service, we try to keep it as same as possible. And we have this. So we still have the new payment and transaction will be created regardless. But we can no longer call this service as a database transaction. We need to make, in this case, API call. So this is just a simple API call, as simple as possible. You'll probably not use REST template like this. You will probably use async calls or something like that to make it more efficient, but the principle is basically the same. So if we run all of this, let's see what we can actually have. So this is stopped. That's good. We have to run all of these, so it's going to take a while. So this one's up. This one's also up, and we just have gateway. While gateway is starting up, it's just a simulation. So it's also same Spring app. It will just route this from, oh, we have a chat. That's great. Thanks. Yeah. So everything's up and running. And let's try our request now. Let's first try with the valid request. So we have an amount of 20 and item amount of 1. So we would expect this to be successful, and it is. So here we also have, again, simulation of 3 databases. So there's a customer, payment, and stock. In payment, if we go to transaction now, we have a successful transaction. If we go to customer, yeah, it was 100, now it's 80, and it should be still 9 here. So that's great. But what happens if I try to do something a bit different? Let's try to send a customer value which is not valid. Let's try to send 100. Same as before. We send it, and we get a failure, of course. We accept that. But what happened to the data? If we go to payment, yes, we have a record of a failed transaction, which is fine. If we go to customer, it was 80. It's still 80 because it failed. If we go to stock, it was 9. However, 9, now it's 8. Now, this is something that's actually a problem here. So what happens? If everything goes fine, we're good. So if the transaction is valid, nothing wrong will happen. But in case the stock service fails, it has no way of knowing that the customer service failed. So the payment service here knows that the customer service failed, and it set transaction in invalid state, which is as expected. But the stock service does not know. It was executed outside of customer service, and from the stock services perspective, everything's fine. So it decrease the inventory, everything's okay. But what we ended up in is inconsistent state. So we have a failed transaction, we have updated customer entities, not updated customer entities, and updated stock entities. And this can lead to a lot of problem. So I think if someone has idea that, oh, you should check, like do a call before to check if you can actually do this on the customer service, that's not gonna be much of use, because you will probably not build microservices system if you have, I don't know, like 5 requests per hour. You will build them if you have thousands and thousands of requests per hour. And it is very possible that some other operation in the meantime will change this value while you actually send the update request again. So this is a problem that we need to do. So let's see why this is actually happening. There is something called a cap theorem, which says that distributed system can be consistent, available, and partition tolerant, but it cannot be all three at the same time. It has to sacrifice one of these things. So in case of ACID, we have consistency and availability. Consistency says that you will always get either the latest write that was made when you request a read, or an error. And availability says that your data will always be available. So if we want to have all three of these, that's simply not possible, because if we have a partition tolerance which says that if some of the elements in the system are not available due to network issues or anything like that, it will not break the entire system. And if we take a look at our Monolith application, if database is unavailable, the system is broken. So it will just not do anything anymore. But in microservices, if one of these is actually not there, if it's dead, the system still runs. It does not run well, but it still runs. So what we introduce there in microservices is this, and we have to now be a bit more creative. So what happened in, I don't know, recent 10, 20 years, something like that, is that some creative guys made an alternative to ACID and called it Base, of course, because we always have interesting names. So Base is a bit more relaxed, and it says that system should be available most of the time, which is basic availability. It should have a soft state, so the replicas may not always be consistent, and it has something called eventual consistency. So what we try to do here is if we do a transaction in a Monolith application, that transaction, if it's not completed, none of its parts will be saved to the data store. So, but what happens is that in the meantime, if someone tries to access the resource that you are trying to modify with the transaction, they will always get the same value. So there will not be an instance where someone would get the partial value out of it at all times. But what eventual consistency says is that may happen that you will get an older value, but eventually it will go to the right value. And that's something that we will use to solve our problem. We will sacrifice hard consistency for eventual consistency. And this is just one of the things that you can do. There are multiple ways that you can handle this. None of them is a silver bullet. So this is just one of the things. And we will try something that we call Saga. It's a pattern that we will try to implement in our microservices in order to achieve this eventual consistency. So let's see how that would look like. We have a payment received, then we have a modify stock, modify client balance, and complete transaction. So this step here can be a bit problematic, because this final step will know the result of both of these, but this one does not know the result of the next action. And the problem that we experience now is due to the fact that all of these operations were final. Once they're committed, they're done. We do not have any way to roll back them. So let's see how Saga can help us with that. Saga is actually, if we take a look at what we have here, in Monolith, these are operations. And in Monolith, because we are using a transaction from an ASIN compliant database, we do not have to think about how this will be rolled back or not, because it takes care of that problem because it has a lot of smart people working on that. It has a transaction log and everything else. So it's able to create that vision of atomicity that either everything will be committed or nothing will. So Saga says, okay, in distributed system, that's not really feasible. So it will be either some solution based on two-phase commit, which sometimes causes more problems than it actually solves. So let's say that we break apart all of these operations as individual undoable operations. And that series of operations is called Saga. So completing all of them will eventually leave us in consistent state. So if one of them fails, we need to provide a mechanism to actually roll back the change. So that once all of the actions, all of the operations that are inside a Saga complete, we will either have a successful or unsuccessful transaction. So let's see how that actually looks like. We will have two implementations in this. One is with Orchestrator and another one is with Choreography. And we'll go through, let's see, pros and cons of both of these. Let's try Orchestrator first. So we'll just stop this one. And again, wait a bit until this runs again, so I can check out the chat. Okay, this one's done. Okay, if I use messaging instead of REST to solve this very easy. Well, that's a good question. I have no idea how, so we can probably make a discussion out of it. Okay. Another protocol. Okay, I'll check this out later. Thanks. Two-phase commit. Yeah, we can talk about it later. Anyway, so let's continue. Let's try the same thing now. So we'll try first. Let's see what we did here. So there's just a little difference here. So everything's the same on the payment side. A bit almost the same, let's say. So what we did here is we use payment service as an orchestrator. So it will actually be the one that will collect all of the results and figure out what needs to be done. So what we did here is we will call this same thing as we had before: create a new payment, create a new transaction, go to process payment here. And here we'll have a bit of a difference. So we'll just update stock. Since the stock is the first operation, we do not need to do anything. If it fails, everything fails and we're good. But in case the customer fails, we need to send instructions to roll back. And this is actually the only difference that we did. So this still fails, and we will still have a failed transaction in case we send an invalid customer amount, but it will leave us in a consistent state after that, because we actually implemented rollback functions on our own. And how that looks like here, because we only have it now at customer service. If we go here and zoom this in a bit, we have a, stock service. Just a sec. There we go. On stock service, we have modify stock and revert stock. The important thing is here is that in this type of pattern, we cannot use like hard values. We always have to have the event that was changed. So in this case, we have a stock details and a changing amount. And we need to send that exact same value when we either modify or revert, because if we just say, I don't know, set stock value to 80, it will not do much. But if we say set stock value to current value minus something that was caused by this event, it gives us actually a rollback point, because if something happened in the meantime, we don't really care. We just want to undo the things that we did. And in this case, we only did an decrement of 20. So let's see how this works. Let's again try just to go here and reset the queries. My index is out of range. Okay. Again, we have 10 and we have 100 here. So that's good. And let's try to send a valid one. And it's success. And I don't think we have to check again, because it works the same way as the previous one. But let's see what happened here. So this one's fine. Stock is 9, which is okay. So let's try to say send another invalid one. And it's a failure, as we expected. But let's see what happened to the stock. It should remain at 9, and it did. Because what we did here is that we had an orchestrator function which actually collected all of the data before deciding what to do with the transaction. And if the data that it collected does not meet criteria, then it will roll back everything. And the corresponding microservices that we used had a method to actually roll back the changes that we did. So let's look at this implementation and pros and cons. So the pros of this orchestrated approach is that we have eventual consistency. Keep in mind that if for some reason customer service failed as it failed now, it does not have to be just because the data was invalid. It could be anything, and that could take a while. That could take a couple of seconds, even more. So even with fail fast approach, we'll probably go up to 5 seconds. So in the meantime, if somebody called the stock service and wanted to know the stock of that item, it would get invalid value. It would get 8 until we initiated rollback. So that's what we mean by eventual consistency. So at some point, if everything works, we will get to a consistent state. But we cannot expect to have it at all times. We can also, in this case, because we have an API call, we can return a result of this process as a response. which can be very useful because it does not require any additional implementations like sockets, server-sent events, or things like that. And also we have a sequential flow. That's something that people may like or some may not like. But I think, in my opinion, it's easier to work in a sequential flow, but it's not mandatory to be like that. It's just good to have that option. But the negative time is a negative thing due to this sequential flow. We have a lot of waiting time. Especially if you use synchronous approach like this, if we do not use mono and flux, which we can, of course, in this case, we will have a lot of waiting time. That's not good. And also we have a single point of failure because if the orchestrator is down, everything's down. So you can't really do anything. And every one of these orchestrators can be a bit too specific. So it's always centralized, like everything that happens always in that same place. So those are some pros and cons, but in our case that we actually did solve this. But there's also some implementation consideration that we have to take in consideration. First thing is, we can execute it in parallel. That would also work. Flux and mono would probably be a better choice to use here. You don't have to actually have implementation for every undo right now. You can just leave it as an interface and implement it once you actually need it. Like in our case, in this specific scenario, we do not need undo operation on customer. We just need it on stock. And also what we have to keep in mind is the rollbacks can fail as well. So this is not bulletproof. So properly designed microservices along with retries, dead letter queues, and circuit breakers, they all play a big part in keeping our data consistent. So Saga is just like one piece of the puzzle that we can use there. So let's try another one with choreography. So this one works fine, but let's see how would that look like if you're using choreography. So in choreography, all of these would be asynchronous calls. So there's no orchestrator. There's nobody actually collecting all of the results. It just has some kind of messaging bus or a queue or something like that between the services, and they just call each other. And in this case, we would have same four services. We would go to initiate payment, modify stock, modify balance. But all of these could potentially fail. So, except for payment service in this case. If we go to modify stock and it fails, we will just return failed transaction to the payment service. Stock service can go to modify balance, send modify balance to the customer service. And if it fails, it will go to revert stock and cascadely go all the way back. And this actually provides us with one more useful feature, is that this is a small example, let's say, and these are relatively fast operations that can happen. But in case of a longer operations, we can introduce additional statuses. Like once the payment service is complete, it will set a status on transaction. Once stock service is complete, it will send another status of transaction, and so on. And we can maybe make a better track. So let's see how that looks like in code. Yeah, of course. We will stop our orchestrator example and go to choreography example.
Damir, I need to step in again.
Sure.
Sorry, could we increase the font size permanently? Because still there is an issue. People are asking in chat so they can see it.
Honestly, I don't think so.
Okay.
If someone knows the solution, sure. But is it just the code or is it presentation as well?
I think just the code.
Okay, I'll make sure to zoom in on every file. Maybe someone knows in chat.
Okay, so shoot, guys, if you know.
wow, a lot of these. Sorry. Payment. I wanted to answer all of these in the meantime, but there's just too many. So unfortunately, it will have to wait after. But we are almost done. So this one's done. The stock and the gateway. Yeah. So in this specific example, we used Kafka as a messaging service. It's just a local development Docker container containing Kafka and Zookeeper, so there's nothing special about it. And we will use that mechanism and messages to pass this message around through everything. So let's just go through what we have here. So the first thing that will happen is the code will come to gateway. And if we go to gateway, just a sec, we have received this request and we just send it to the Kafka topic. So this is just smallest amount of code that you can do to send this. So you probably not do this in production, but just for demo purposes. You would send a new payment to the topic. Notice the first thing here that happened is that we have to return response now. Otherwise, we are just waiting for something. Because once we send it to the topic, we have no idea what will happen next. Some services will take care of that message and pass it around, but we are not really sure what will happen. There are mechanisms, of course, that you can use, like server-sent events or something like that, but it will require a bit more implementation than this. So what we did for the demo is that we have two endpoints. Once you get an OK, then you can just either poll or something at this endpoint to figure out what happened. And another thing that's a bit interesting here is that we actually have to set transaction ID now, because the transaction ID is in choreography example. It was assigned as an automated value that database would generate to us as an ID. But here we have no knowledge of that ID. So we have to have some kind of ID generation mechanism or something like that inside our system that will assign these IDs and let's know, it's like a ticketing system. Let know the client who actually requested that, the number of the ticket it should be waiting for. So here, instead of letting database set it up, we set it up. In this case, just a random UID, probably not use something like that in production. And the next step would be the payment service. Inside the payment service, we have a listener. Sorry, there we go. That listens to two topics. One is new payment topic, and the other one is transaction update topic. So eventually this circuit will close and we will have something, either fail or success. And inside the service, we have just almost the same thing as we had before. We have a create transaction, which is invoked once we get the new payment. We have update transaction, and we have get transaction details, so we can pull what's happening with our transaction. And then on the next step, if we go, the next step is stock. And if we go to stock, again, similar thing, but with a bit more difference. So as we have seen here, it just goes back and forth. It just rolls back. So in case the stock fails, it needs to immediately notify the payment service that he failed. So we will no longer go any further because we failed and there's no point. So in this case, if modify stock fails for any reason, we will just send a notification back that will actually be just a transaction update saying that we failed. We can also add some additional data like who was the source or something like that. And also the last one that we can go to is a customer. And in customer, it's again, basically the same thing. We have modify balance and send failed transaction, but in this case, send failed transaction will not go as a response back as we had in Orchestrator to the payment service. It will just go back to whoever called him. So it will just go back to the stock, and then stock will do its job and just proceed again back to the payment service, which will complete this transaction. So let's see how this works in reality. Yeah. So if we go to, again, since everything started, just to make sure everything is reset, it's 10:10. Customer is on 100, so that's fine. And let's try to send a valid one. And as you can see, we only got new as a response. That's because the gateway service at this point does not know what happened to this transaction. We need to have some additional type of mechanism that must happen in order to get the status back. In my Postman example, it's just another request. But please keep in mind that I got the ID that I need to use. So yeah, in this case, it's complete. The ID that I've sent is fine. And if we go check it out, this is updated, that's fine. The stock is also fine. And payment should have a transaction, which is complete. So let's see what happens again if we try to send invalid one on the last one. Again, 100. If we go, again, we have just new because that's the way it works. And if we go and check, it's failure. But even though it's failure, that's something that's expected. And we can make sure that none of these values are changed. There's also one interesting thing that we can use here. So in orchestrated example, since we are using the direct API calls, in case one of these services is for some reason unavailable at this point, but maybe it was unavailable for like, I don't know, 1 minute or 2 minutes or something like that, like too long for a retry, but it will be really soon back online. In this case, we have some may say good, some may say bad example. Let's say that we kill, for example, customer application. Let's say we don't want that. We just want to kill customer. And we want to send same type of request again. So it's 20. And we send, so one of our services is entirely dead. It's not working. And we go to details and we go here. We have a status of pending. Why? Because the circuit, this saga did not complete. Since we just use a messaging system in between services, this message can stay there, especially in case of Kafka, indefinitely. So as soon as we start this up again, and try this again, this service should pick up leftover message and complete our transaction. So this is something that in these, if we're using messaging systems in between, this is something that we can use, and that if we design our system in that way, can be really useful. However, it can also be a bit not so useful, because if we have other mechanisms that that will try to roll back transaction, let's say we have a circuit breaker saying that after a certain amount of time, if something is incomplete, just roll it back. And then that service comes online and processes something that was supposed to be rolled back. So that's also something that in case we want to use this, we have to be careful about. So let's look at the implementation that we have here. So the good thing is this is really fault tolerant. So as we can see, the services don't even have to be online in order for eventual consistency to happen. If we have relaxed roles, let's say, especially in analytical type of data and things like that, where we don't care if one increment happened like now or 10 minutes later, this can be really useful. There's no single point of failure because all of these services work with each other. There's nobody actually orchestrating them. Every service knows where to send and where to send back. And it gives us a bit more tracking possibilities about where this transaction is, in which state it's currently in. The downsides can be that you can't return result directly in any easy way. I mean, it's possible, but it requires a bit more code around it. I think the most popular, I think that we have flow on recently, was using server sent events in case that we use a reactive approach to all this. But again, it's still more code than it is in case of orchestrator. Transactions can be stuck, as we have seen. That can be either a good thing or a bad thing. So as you design your system, you can either use it to run away from it. And the third is that you need to have additional component for ID generation in order to keep these IDs consistent. And so, yeah, all of these points that we have here, we already talked about during while we were looking at code. And this would be, let's say, choreographed example of how this could happen. There are also things that we need to keep in mind. There sometimes we can get parallel, like we can have race conditions in these things. If we get two of these, like two messages for decrement on a queue, or let's say either from an orchestrator that want to decrement some value, and we are relying on a value that we have just got to actually see what we need to do. Let's say we have two parallel actions, one say -10 and other says -20, and the current value in database is 100, and they both get the same value, 100, and they decrement to 90 and to 80. So whichever saves last would actually keep the value, and it will leave us in inconsistent states. So this does not solve race conditions and things like that on a service level. This just helps on system level. So for the service level, we will still need to use something like pessimistic locking or optimistic locking, any type of mechanisms that we can get from database, or any type of patterns like versioning and things like that that we could get from NoSQL databases. So this is just one piece of the puzzle, and also that's something that will always slow us down. And final thoughts about this before we end and take some time for questions is that I hope that in this short presentation, we have seen that managing data consistency is not trivial. I mean, at least it's not for me, and it's really, really difficult to do. And there's basically no silver bullet that you can use that says this solves all of the scenarios that we have. And this was a really simple problem. and we still did not solve it completely. We still do not have a mechanism inside there that says if rollback fails, what to do, and if we have a race condition, what to do. They're solvable by the things that we talked about, but it still needs additional implementations. And also that we talked about Saga is just one pattern inside the system that we can use. Retries, timeouts, circuit breakers, dead letter queues and things like that can also be a good thing. And there is one thing that's missing in this here is that even with all of these things, at some point errors will happen and our data will go into inconsistent state. So there's one thing that also needs to be part of every, let's say, larger system which cares about consistency a lot is reconciliation. That can happen periodically. Banks do that a lot, like at some point because they lose things all the time. And at monthly or quarterly or weekly basis or something like that, they actually run like huge processes to reconcile data that they have. So this data should be minimized as much as possible to keep these processes as rare as possible and as small as possible, but it's nonetheless part of the thing that we need to worry about. And I think at least my experience, the best way to avoid these problems is to design around them, not code around them. So every time that we have a call that spans more than like 2 or 3 microservices, maybe we need to rethink, is this really a good thing? Is this the only thing that we can do? Maybe weigh pros and cons to see maybe our microservices are not divided optimally, they're not really good enough. So the first step in solving this issue should be design itself. And also the last one is there's nothing wrong with Monolith. So we have seen how much code we need to actually fulfill something that we did in Monolith in just a couple of methods. So each project, each specific system has its own requirements, and we need to figure out if this is something that that microservices are good for or not. And we always have to think about, budget, tech constraints, deadlines, and things like that. And I think as a purpose of this meetup, because it just scratched the surface, it's something that we can talk about for hours and hours and days. And I think people still don't have a silver bullet solution, as I said, this is a creative process, and this is one of the fine examples of that creative process. So you can do, you have plenty of patterns at your disposal. You have plenty of combinations that you can do, and fitting them all together and trying to make everything work is just one of the most beautiful things that I love about this job. And yeah, so a lot of people, I think, in chat asked about the code. So code is purely for demo purposes. So, but if you need it for any reason, you can find it on GitHub on this link. I think you'll get this presentation, either Merima or Slavica will post it somewhere. And yeah, thank you for your attention, and I hope you liked it.
Okay, so I want to say thank you for a great presentation, Damir. Definitely our chat is on fire. We have also 2 questions in our Q&A section. So I'm not sure if you want to go through all questions people asked, or you want me to read it, but there's a lot of them.
Okay, so yeah, I think I'll go through questions and answer first because it's easier.
Okay.
Okay, so how would one handle race condition in Saga pattern using orchestrator? So before action is reverted, someone tries to increase the amount in stock by 20%. Okay. I actually haven't thought about percentage. I would always think about that it had to be an actual value. So as we talked about it, if we go back, oh, sorry, again, if we go back to here, here, yeah, we have like decrement stock and increment stock. So the entire point is that we can work with the concrete increments and decrements. So if we have something that's in terms of percentage, I don't think that's possible, because percentage will change all the time. We'll probably need to place that implementation if we got it from percentage in a way that's, let's say I will take 20%, we will have to convert it into a real number that was valid at that point, and then send it further as an event. Okay, so next one, Q&A. Wow. Maybe you could visualize the messages that are transferred via Kafka. It would be easier to follow. Thank you, Milan. I tried to do that, but maybe I failed. Come on. With this. So this would be a message. Yeah. Yeah, I'll think about it. Thanks. Good point. Okay, so assume the data is being written to and being retrieved from multiple databases for a single service. Share DB. Are we depending on the DB driver program to handle replication and fetch, or go for atomic transaction and re-trigger? Or would it be better for caching databases to update DBs to consistency, a better option? Huh. Come on, just goes. Okay, so I'm trying to understand the question, sorry. It's being written and being retrieved from multiple databases for a single service. Okay. Sharded DB. Oh, sharded DB, not shared. Oh, okay, okay. That's a tough one. I would say in my specific case, I would always defer everything that I can to database unless I have to do something manually on my own. If there's a mechanism inside the database to do that, I would go for that. And if my scenario does not allow me to do that, then I would go to actually try to do atomic transactions and re-trigger them. I hope that, I don't know, I hope that answers your question. Okay. Damn. Okay, isn't Kafka or any communication channel the single point of failure? Yes, it is. Yes, it is a single point of failure. But at some point, everything's a single point of failure. At some point, we will just come to the fact that electrical energy is a point of failure, because it is. So in all of these things can just short out, die, and things like that. But what we are trying, what idea is that Kafka seems really resilient on its own, and at some point we'll have to rely to something. Same as if we did, let's say, on a database, and we have an app above it. If database fails, then everything will fail. So yeah, this is absolutely correct. But you are I am delegating part of the problem. I'm not delegating entire problem. But it's a valid point. And okay, in real life scenario, would you implement Saga mechanism as shown in presentations or use existing Saga framework? Honestly, I never used this framework, so I cannot say. I would, in real life scenario, this is basically how would I do it. So I'm really interested to see how this works. So Nevin, I think I know who you are. You can ping anytime and show me how this works. So I would be happy to see it. Usually I would just write something on my own. Okay, more. How much more time do we have? Narima, Slavica?
Around 15 minutes, but we are okay with the discussion, so you can answer a few more questions, let's say two,
okay.
3.
Okay, thanks.
If you want, we can like connect you with some of these people if you want to answer like via email or something.
Well, sure. Why not? I think there's my email on GitHub there. So anyone who wants, just shoot an email, or you can send my Symphony email or Slack or whatever you want.
Okay, great.
So that's great. Okay, assuming a high number of systems involved in sequential flow, would it be better for maintaining an intermediate state and update once the other systems can serve the request, like one prioritized something, and when stock will be, it will be deployed. This is something I think most similar to a two-phase commit thing. So that's something that we can get if our database is supported, and to have like reservations, and once all of the criteria is met, then those reservations are committed. I would not say that if it's better or not. I would say it was just depend. And if high number of system is involved in sequential flow, I would just actually probably be against it. So because it will, one of the things that two-phase commit is a bit tricky about is because it creates a lot of traffic, and the more components that you have, you'll have just more and more traffic. If I have a lot of systems involved, I would probably just go as it is. Then again, it would depend on requirements entirely, as everything. Okay, this is the last one. Thank you, Milan. You mentioned that eventual consistency provided by the messaging system could cause problems with timeout-aware scenarios. Would you suggest a timestamp timeout label messages? This would cause messaging system to raise a force failure of a message and trigger rollbacks. Is this beneficial at all? Yeah, that's actually exactly what I would do. But as I said, it's a trait that can either be exceptionally useful, or it can be something that can backfire. So this, what you just explained, is a good way to prevent the backfire. But as the question says, is this beneficial at all? That would all depend on the scenario. That would all depend how soon do we need the data. Let's say in analytical data, if we're just building metrics that are sometimes on daily basis and things like that, we don't really care if the service was offline for 6 hours. We just want to know that as soon as it comes back online, it will process everything that's there. So in this case, having these timestamps and things and rollbacks, it's not beneficial at all. We don't need it. But in case if we need something to happen fast, if we need to react, if we are not getting consistent state on, let's say, a client UI or something like that, if transactions or purchases are getting stuck because of something, we would probably want to have something more time aware to just kill it and repair it as soon as possible, which can again be more than 5 seconds or something like that. So in that case, I would kill those messages and just keep it offline to avoid further inconsistencies. Okay, so in chat, I think there are 51 messages, and sorry, I just can't go through all of these. It will take like half an hour. I'm really sorry. But if you have any questions, I will take these. I don't know all of your names, but if you can send them to either email or anything like that, or GitHub or anything, I will be happy to go into discussion because I can learn something as well. So that would be great. And thanks for all the questions, and thank you guys for attending.
Thank you, Damir, for amazing presentation. You put everyone on fire, definitely. So we will share your email, so people you can reach to Damir. He's available for that. Thank you, Damir, also for that. So for the ones who are still strong and on fire, we can go to our Kahoot quiz. So it's like a school time to see how much you paid attention to everything Damir said. And for the fastest one, we prepared some amazing prizes. For the first place, we have some JBL 500BT headphones. For the second place, we have wireless charger. And for the third place, we prepared Symphony backpack. So I will share my screen now for our Kahoot quiz. And what you need to do when you register and follow the instructions on the screen, please input your full name with the city where are you from, so that we can contact you later if you are the winner. Okay, let's start with this. Okay.
Okay, Slavki, maybe turn on the camera. Just so you know, you are muted. We can't hear you.
Okay, just a second. Can you see my screen?
Yes, everything's fine. You have to just put it in full screen.
Okay, just
at the top right corner.
Okay, perfect. Thank you, Marima. So guys, please put your full name, so name and surname, so that we can contact you later.
What are we aiming for, Slavica?
I'm not sure. We're going up fast, so I believe maybe let's say 70.
Let's say 70.
Can we reach that number?
I think we can reach 80, but okay.
Okay, let's see who is the right one.
But I'm really ambitious, so it kind of stopped now. Guys, I said 80. Please.
Okay, I think 60 is okay. Okay.
70.
Just few more, maybe 65.
Maybe 65.
If not, it's okay. We can start, so we don't lose time. Okay.
Okay, 63.
Hype.
Come on, one more. Oh, 66. Sorry.
Okay, perfect.
Can't stop now. I said 80.
Okay, we can start now, really.
Yeah.
Okay. So what does KAP stand for? Please choose the figure on your screen for the right answer. Five more seconds. 4, 3, 2, 1. Okay, 29 right answers. Let's go to the next one. Okay, actually, Bamane, I'm not sure if I'm saying it right. You're the first one, so congratulations. Let's go with the next question. Consistent, according to KAP, means that. Okay, 5, 4, 3, 2, 1. Let's see how you answer this one. 12 right answers. So, okay. Milan Mitric is on first place, Milica Ilic is on second, and Mida is on third. Let's see if that will change with the next question. If we are working with a CID compliant database, Atomic will ensure that. Three, two, one. Let's see. Oh, 56 right answers. Congratulations, guys. You are right with this one. Okay, so Milan Mitric is still on first place, Milica Ilic is on second, and Stevan Čović, maybe, okay, is on the third. Let's see what happened next. Does consistent in ACID mean same as consistent in CAP? You must construct.
I think it's a fluent. we were out of answers, guys.
Just a comment. I voted to place the first answer as correct, but I think.
Okay.
I mean, pylons must be correct.
Yeah, we have 37 correct answers. So great job, guys. Let's see the list. Stevan Čović, I hope it's Čović, is on the first place now. Sasha is on the second, and Nitai Ajanel is on the third one. So Sasha, please comment in the, put your full name in the comment, please, so that we can recognize you later. Okay, another one. If we have single application with single database, we achieved what? One. Okay, 42 people answered correctly. Congratulations, guys. Let's see what's next. Oh, Stevan Čović is on fire. He's on the first place. Sasha is the second one, and Nitai Ajanel is on the third one. Let's see if something will change soon. Sixth question. With microservices implementing database per service pattern, we risk what? Shoot, guys. Three, two, one, boom. Okay, 50 of you answered correctly, sorry. So let's see the, okay, Stevan Čović is still the first one. Sasha is on second, so nothing is changing actually. And let's see what's happened next. So Stevan Čović has the highest answer streak of 6. Congratulations, Stevan. Okay, the next one, 7th. What is a relaxed alternative to ACID that we can use microservices? Okay, 5 more seconds. 4, 3, 2, 1. Let's see how you answered this one. 50 of you answered correctly. Congratulations. Is something changing? Okay, 3 of you are just like on fire.
Sasha, we know you're busy answering, correct? But like, just write your name in the chat box, please, please.
Yeah. Okay, the next one. Eventual consistency means that. What, guys? Shoot, 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 shoot. Maybe we can change the score. 5 more questions, 5 more seconds. I'm still on the question section in my mind. Okay, 47 of you answered correctly. Let's see the score. Sasha, you are on the first place. Again, and we need your full name so that we can...
He wrote it. It's
okay,
Sasha.
perfect, perfect, perfect. Thank you, Sasha. Let's continue. How do we achieve rollback in Saga? Pa, 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 pa. I silenced the sound of Kahoot so that they can concentrate. 5 more seconds. 3, 2, 1. Let's see how you answered this one. 52 of you answered correctly. Awesome. So Sasha is keeping the first place still. And I think that one more question has left. So the last one. What of the following is a downside of orchestrated Saga? 5 more seconds. Let's see if something will change on the score or we have the winners. Same ones. 30 of you answered correctly. Let's see the podium. Third place is Anand Porovic. Congratulations, Anand. You have our backpack. Aldin Kovacevic is on the second, and the winner is Stefan Chovic. Congratulations, Stefan. Woohoo! Thank you. So runners are
sorry, up. Sasha, we put pressure on you now. Now you didn't win.
Okay, guys, so you know the prizes. The winners will be contacted by me, and please share your address so that you can receive the prizes we mentioned before. So once again, I want to say big thank you to Damir and his amazing presentation. We learned a lot from this one, and I will leave the stage to Merima. She has one more thing to say.
Yeah, thank you, Damir, and thank you all for participating. We hope you learned a lot and we hope you had fun. If you really liked our vibe, make sure to follow us on our Symphony site and check out the open positions that we have in all of our hubs, and make sure to follow us on social media so you can get regular updates about our Symphony community. And thank you again. And that is it.
Thank you very much for your attention, guys.
Thank you.
Thank you. Bye-bye. See you soon. Bye.